Today we're covering orthographic projection and manual drafting standards. I'm going to be drawing the 3 standard views for this part up here, and along the way I'm going to talk about different standards I'm applying, different rules, different lines, and so on. This is called the isometric view. We are going to use this to determine what views we will be drawing. There are 2 standards in the world. We will be focused on ANSI, the American National Standards Institute. Over in Europe, they use ISO, the International Organization for Standards. And for this exercise, the main difference is how it's projected. So they have different right and top views than what we will be doing today. So what that means, we have our part. For ANSI, there's 2 ways to think about it. The first way, you could put this in a glass box. Picture in the glass box, when you look straight at it, this is the front view. If you were to look at the right side of the box, it would project this profile right here. So this is the right view. And the top would look like that. So that's the glass box. We're going to draw those 3 views. The front, top, and right are the 3 standard views. Alternatively, you can think of it as placing the part in a bowl. You got a nice little glass bowl here. Put the part down here. And if you put the part with the front of it facing you and the bottom of the bowl, and then roll it up the sides. So I roll it up the right side, which means this is my right profile. And I roll it up the top, that is the top profile. Now that's for ANSI. If you want to know how ISO does it, we can flip the bowl over, treat it like a ball, place our part on top of the ball. The front view remains the same for ANSI and ISO. The difference is now I'm going to roll it down the side. So the right view now becomes the left side of the part, and the top view now becomes the bottom of the part. You can imagine how confusing that can get if you're not aware of the 2 standards when you are looking at engineering drawings. So we're going to use ANSI. So we are with the glass box or the bottom of the bowl, and we are going to project the front, top, and right side of this part. We're going to draw it to scale neatly as an engineering drawing should. So first we draw the front, then I'm going to project it to do the right, I'm going to project it up to do the top. There are 3 more sides, but a lot of them are redundant. So the left side is a mirror of the right, we don't need that. The back is the same as the front, we don't need that. So we're going to stick to the 3 main views for this. Given an isometric view, this tells us what the front view is. If we were not given that, and you as an engineer designed your own part, you get to decide what the front view is. The front view is picked based off of what display state gives us the most features or the most detail of the part to tell us what it is. Since you're given the isometric view, we are going to go off of that, which makes life a little easier. So we have the front, which is right here. We have the right, and we have the top. I'm going to draw the front view down here in the corner, so I have room to project it straight up for the top and straight over for the right. So everything is drawn to scale. Down here in the title block, you can see scale 1 to 1. We have dimensions up here, so this is when it says 2 inches, I'm going to draw 2 inches. We're going to start with all visible lines. So we have different line types. First is visible lines. So every feature you can actually physically see in the view gets a visible line. So it's going to be a visible line here, here, the profile, and this circle. Because that's all I can see in the front view. These holes are still here, but I can't see them yet. So we're going to draw all visible lines now. I'm going to start by drawing my 2 inches. make sure I have plenty of room. And make sure I'm parallel. So I'm going to draw these lines first. So I'm going to draw 2 inches from here. And the visible line is going to be thick and solid. It's not broken at any point. I know the height of the part is 2 inches plus a radius of 1 inch, which gives us 3 inches. So I'm going to go 3 inches straight up. Again, making sure I'm parallel as best as I can. Start at the 8, I'm going to go to the 5. So I'm going to do that again over here. Actually, I'm going to leave it at that for neatness. So I went 2 inches up right here, then I have a radius of 1 inch. To do that radius, we're going to use a circle template and the 2-inch diameter circle. I'm going to hold that up to where it is tangent over here. And I'm going to go around right here to where it becomes tangent on the other side. Then I take my ruler and fill in my last 2-inch line down here. Like that. So there is the front of my part. What is left will be the visible line for this shelf. So it's 0.25 of an inch up. I'm going to take my ruler. 0.25, I'm going to put a line there, go 0.25, put a line there, and it's a visible line going across the part there. Hole, it is up 0.125 of an inch from this bottom base here, so I can come up 1 inch, 0.25, which is right here, and it is over 1 inch. It's in the middle of the part, so I'm going to put my ruler here, come over 1 inch, and I'm going to make a circle. From there, you can take your circle template, find your 1-inch hole, center that on the part here. Mine's going to be on the top dash, and draw the circle. So there is the completed front view with all visible lines. Next, I'm going to draw the right view over here, and it's going to be projected straight off. I'm going to give myself plenty of room between the two views for dimensions and stuff later on. So first, I know the length to be 0.1 or 1.5 inches long. So I'm going to take my ruler with the inch side, and I'm going to make sure I'm projected exactly off of that part over to here, and I'm going to go 1.5 inches right there. Next, I'm going to go 3 inches up, so I have 2 inches plus 1 inch radius. I'm going to take my ruler and go 3 inches up. Next, I know my thickness to be 0.25 for that and over here, so I need to come in 0.25 on both sides and finish off the right profile. So the 0.25 is also projected straight off of this view. And if I was smart about it, we can do this all at once. Draw this line over to right here. Then we can come over here and project it still off of this top of this part over here. And you can't see that. So off of the top of the radius there, it's going to come straight over to the top of this part. And we're going to come over 0.25 again. Then connect the dots. I'm going to go from here all the way down. So there is my completed right view with all visible lines. Next, I'm going to do the top view. So it gets projected straight off of my front view, straight up. It's going to be 1.5 inches by 2 inches. I'm going to start with a rectangle first. So I'm going to line my ruler up here. And I said it was 1.5 inches tall. So 1.5 inches tall. And it will be 2 inches wide. Easier to do it this way. So I'm going to start at the 11 down here, project it straight up, start at the 7, and I went to 5.5. Then I can just close it off because I know this is going to measure 2 inches. There and here. That way it stays roughly parallel. So all visible lines are thick, solid, unbroken lines. The top view still needs a visible line for this feature here. I can't tell, it's a radius, so it's a straight visible line, and I need these 2 holes. So that one is down 1/4 inch. So I'm going to come down, mark my 1/4 inch there, and over here, and then I can draw that line. Like so. For these 2 holes, they're located 0.5 inch up and over for both of them. So I can take my ruler, come up 0.5 inch on both sides here. And then I can come in I put my ruler there. 1 inch to 3. I'm going to come in 1/2 inch here, mark it, and come in 1/2 inch on this side and mark it there. So those are the 2 centers for my holes. Next, I can take my circle template. The radius, well, I'm giving it a diameter because it's a complete circle now. So diameter of 0.375, 2 times in both places. I'm going to find my 375, which is right here. And I'm just going to put that lined up with my hash marks. For both circles over here. So there are all visible lines for our drawing. Next, we're going to go over hidden lines. So hidden lines exist for all features that are still here, but we can't see. So the top view, this hole is still here, but I can't see it. So it gets a hidden line on the top right here. Hidden lines are lighter than visible lines, and they're broken with a dash. So they're equal dashes, and they're projected off of the other views. So I'm going to use this circle and project it straight up through there, and I'm going to add equal dashes up here. Same on this side here. So those are the hidden lines for that hole. Next I can do hidden lines for these two holes, because for my front view I still have these holes here. Can't ignore them. So I'm going to project it straight down off of this hole. And draw my hidden lines here. Your hidden line should always start and end with the tangent line. You should not have a gap with the beginning of the dash. So those are those hidden lines. Next is the right view, which gets hidden lines for both holes. Again, it's projected straight across. So make sure you are parallel. And we come across, and we can add our hidden line there. And our hidden line here. Alternatively, you could also measure that. It would be 1 inch since that's the diameter there. So from there, we're going to now cover, oh, I forgot these ones. So to do these ones, you're going to have to measure them. They're 0.5 of an inch in. You're going to come in here. 0.5 of an inch will be right here. Put a nice little mark. So that's the center of that hole. I'm going to take my circle template again for that 375 hole. Center it there. And then I mark the outsides. And that's how I'm going to do my hidden lines. So there are all hidden lines. Next, we are going to cover center marks and center lines. So all circular features get center marks and center lines. We're going to start up here again. I'm going to do center lines first. So center lines are a long, short, long line. It's similar to a hidden line, except for the different line lengths. So what that looks like is, I'm going to project it straight off of my hole again, center it up here, and I'm going to start with a little one in the middle, and then do 2 longer lines on the outside of it. So there is a center line for that hole. Next, I'm going to do the center line over here. So every hole that is shown with hidden lines is going to get center lines. Next up, I'll do this hole over here. Hopefully it comes out better. Then I'm going to do these 3 holes here. Over here, the hidden lines, there are 2 holes in this view. If you look on the part, we have the top one and the bottom one. They are in line, so we can only show one at a time because they're stacked, and it just appears normal. So in this view, I can only see there's probably 1 hole, but the other view shows me there are 2. So I'm going to project it straight down again right here. And I'm going to do some more center lines there and here. And over here. So those are all the center lines. Next, we're going to do center marks. All circular features that are visible, so these 3, will get center marks. Now, center mark is a little cross in the middle and then extension lines coming off of it. So I'm going to line this up again and draw the first part of the center mark. Then I'm going to line it up over here. and draw the second part. So there is a center mark for the large hole. So this view is completely done now. Next, I'm going to do the center marks for these two holes. So they are in line again. Everything is projected. Do my little cross. And I forgot to do the extension lines over here. And extension lines over here. You'll notice when I line this up, I'm also lining it up on the bottom view here. So this center line is lined up with that center mark. So there is the completed drawing with all visible and hidden lines, center lines, and center marks. For the title block down here, the title block gives us general information such as basic tolerancing determined by decimal places on the dimensions, the standard, so we're doing ANSI, so that's listed right here, the projection standard, which is right here, which solidifies the ANSI, which is our glass bowl or glass box. You have some kind of company or organization down here. Material, I'm going to write NA, not applicable. Drawn by, I'm going to write my name. For engineering drawings, they will always be all capital letters. Date, put the date drawn. I think it's the 28th, losing count of the days. Sheet 1 of 2, so it's going to be sheet 1 of however many there are. I'm going to be doing 2 of these, so it's sheet 1 of 2. Next is scale 1 to 1, that means 2 inches. I drew 2 inches. Revision, that is how many times has a part been revised or changed. So this is revision A, that's the original part. Size is the size of the paper, so it's size A. So if you're looking at it digitally on a computer, you know what size paper to print it out on. And that is it for manual drafting. Now, since we have this drawn, we're going to go over some dimensioning. We're going to go over the contour rule, the extension lines, and dimension placement. So I like to start high level with the overall block dimensions. The contour rule, I'm going to keep referring to it, states we're going to place a dimension where we can see the feature best. So I'm going to start with the overall height. I'm going to place that over here on this view. The contour rule also states we're going to place the dimensions inside the views as much as possible. So I'm going to start with extension line. The extension lines are thin and should never make contact with the part. So there's always going to be a gap there. I'm going to pull the overall height of this part over here to place it between the views. And it's going to come off of the top here. And off of the bottom here. So those are my extension lines. You'll notice they do not make contact with the part. Next is the dimension line. So for the dimension line, it will make contact with whatever it is pointing to. So for me, it's using these extension lines. I'm going to leave a break in the middle. It gets arrowheads. So if the line has an arrowhead, it's going to be touching whatever the arrowhead is touching. And then right here, I'm going to place the dimension of 3 inches because we have 2 plus 1. So I'm going to write 3.00. I'm going to stay consistent with my decimal places because they mean something down here. It determines the tolerance. So that was 3 inches. Next, I'm going to dimension the thickness. Well, I'll stick with the overall dimensions first. So I have the height. I'm going to need a width and a depth. The the contour rule says place dimensions between the views as much as possible. So I'm going to put my width off of this view up here. And the width is 2 inches, so right, 2.00. It is also an ANSI standard that these dimensions are breaking the lines. So an ISO standard would place this on top of the dimension line. It would also make this dimension rotated vertical along with the dimension line. So another difference between ISO versus ANSI. I also dragged it out farther than I needed to, so I could nest smaller dimensions inside of it, so it looks neater, and that's part of the contour rule. So next I'll do the overall height here, which is 1.5. I'll pull that off to the side here. And again, with my break, I'm never actually touching the part with my extension lines. Dimension line gets arrowheads, and I forgot to leave my break. So that's 1.5 inches. So again, with the consistency on the zeros, 1.50, not 1.5. So now I got my height, my width, my depth. After that, I'm going to move in and locate my holes. So, well, actually, I'm going to do details first. So I'm going to do the thicknesses of these two walls. I'm going to place those dimensions in the right view because I can see how thick it is. Over here, this is the same thickness, but I can't see what this is. It's just two lines flat on a face. I can't tell. Same with up here. So over here, I can see that is the actual thickness of the wall. So for the top, I'm going to come straight off. Again, with the break between the part and the extension lines. If it's too close together, I cannot fit the dimension in here with my dimension lines. So I'm going to place my dimension lines on the outside with my dimension. So I'm going to draw my two lines here and here with my arrowheads. And then I'm going to write 0.25 over here. Another standard for ANSI is there are no leading zeros. So this dimension is 0.25. I did not put 0.5. Then down here I'm going to mark it again. We can share extension lines. So for here, again, it's a little small to put in, so I'm going to put it on the outside. And if you put it on the outside for a vertical dimension, you're going to add a horizontal line and then a dimension. So it's going to be 0.25 over there. So now all that's left is to dimension hole locations and hole sizes. So in order to do that, every hole needs 3 dimensions. You're going to have to dimension an x coordinate, a y coordinate, and a diameter or some size. So I'm going to start with this hole. I'm going to do the x and then the y. Contour rule says keep it between the views, so I'm going to draw it right here. Notice my dimension lines do not touch each other, or my extension lines. This extension line goes into the part because it's pointing towards the center line here, but still not touching it. And that hole was located 1.5 inches because it's 1.25 from the shelf and the shelf is 0.25. So 1.50. Next up is the x dimension for it. I don't really have room up here for it, so I'm going to put it on the bottom. Up here would be ideal because it's between the views, it looks neater. But again, I don't have room. I drug that one too far down, so I'm going to place it on the bottom here. So again, the extension line goes off of the center line, but doesn't connect to it. And it comes off of the bottom of the part there. So keep in mind, we're never going to touch the part with our extension lines. So this is 1 inch, so I'm going to write 1.00. And I'm also not including the inch symbol because an ANSI standard is inches, so we don't need to keep writing that over and over again. So that defines location for that hole. Next are the location of these holes. With our center marks, it allows us to make an assumption that they are on the same line. So I only need to mention a height one time. So they are a height of 0.5. I'm going to place it over here under this dimension. And I'm going to come off of the part here. I'm going to share that dimension line, or that extension line. And then I'm going to point here and here. Now, this is smaller than that dimension. I couldn't fit the dimension and dimension lines neatly, but it's larger than these ones. So I can have the dimension lines outside and then place the dimension inside. So that dimensioned both of them. Next up are the distance between them. I'm going to dimension the holes together first, and then dimension that to a side. If there are two holes, usually they are related to each other, and the distance between them is more important than the distance to the outside, but you'll get to that later on. So I'm going to drag out the extension line here, and the extension line over here. Then, so for right here, I can fit the dimension line and dimension cleanly. Out here, it's going to get a little tight. So we're going to see what'll look best. If it starts to get too cluttered, I might place that dimension out here just so it looks neater. Let's do a different style. So let's just come straight in and out. So I'm going to place my arrowheads. And what I did here is I'm going to place the dimension out here. So it was 0.5. And then I'm going to place my arrowheads on the inside here. And they were 1 inch, I believe. So that fully defines locations for the holes. Next, we're going to define the size of the hole. So let's do this one first. This one has a diameter of 375, a diameter of 1 inch, make it a little easier for us. And we're going to draw, there are no extension lines, only dimension lines now for holes. And it's pointed towards the center, it touches the outside of the circle and it comes off. And then it goes straight. We have an arrowhead. So if it has an arrowhead, it is touching the feature. Then we're going to write diameter 1 inch through. So we have a diameter symbol. I'm going to make that line a little shorter. Give me a little more room here. So I'm going to have a diameter, which is a circle with a dash, shown right here. Diameter of 1 inch. And then it's not necessary because I can see in other views, but you can write through all caps THRU, and that's indicating that that hole goes all the way through the part. So that hole is fully defined now. Next up are these two. We're going to draw the same angled dimension line pointing towards the center of the circle with our arrowhead there. Then we have our straight section up here. And that is going to be a diameter of 0.375 through. And they are 2x, so that means 2 places. So I'm going to write 2x. That might not fit nicely. I'm going to go ahead and make that a little shorter. 2x diameter, 0.375. I don't like how messy that one got, so I'm going to go ahead and fix that. And again with the through, indicating they both go all the way through. So now all the holes are located and fully defined. All that's left is this radius right here. So that radius is 1 inch. And to do that is dimensioned similarly as a hole. You're going to put in, so the center of this arc is about here. You're going to eyeball that with your ruler, and that is where your dimension line will come off of. So if you want to get exact with it, you can go ahead and put a dot and then come off of it over here. And again, the reason is because this points towards the center of that radius. Then you have your straight section here. And then to mark the radius, it's going to be an R and then the radius value. So it's simply R 1.00. And that fully defines this part.